All right, so I am going to go through Chapter 5 Notes, Part 2 very quickly. And I know I talked about this with AM class. I'm not sure if I went over this with PM class, so I will do my best. So we talked about how the building block for bone is cartilage. And whether it be, the first time you grew your bones during fetal development, or if there's a break or a fracture in the bone, the building block for bone is always going to be cartilage. The process of building bone off of this cartilaginous template is called ossification. By age of 2, most of the process of ossification has occurred, with exceptions of a few places, which is the epiphyseal plates, those are the growth plates at the ends of our long bones, the bridge of our nose, ears, the cartilage that attaches our ribs to our sternum, and our joints. So this is looking at an epiphysis of a long bone. I'm not sure if you can see my cursor or not, but I'm rolling over where it says epiphysis right now. So you can see the light pink around the dark purplish and white. That would be the yellow and red marrow. Then we have the trabeculae of the spongy bone, and then you see that really purple epiphyseal disc. So that's cartilage that's showing there in the growth plate. So as I mentioned before, the process of converting that cartilage frame, if you will, into bone, that process is called ossification. And basically what's going to happen is that cartilage is going to be built to replace bone, or bones will start out as cartilage during fetal development, and then there's a bony cast kind of put on the outside. I think about the cartilage is almost like a paper mache. If you ever done paper mache, you have something that you are going to put the paper mache around. Well, whatever, let's say it was a balloon. The balloon would be the cartilage, okay? And then the paper mache that you put around the balloon to make it shape would be bone. And then what happens is that the cartilage that would be on the inside of the balloon, say, would slowly get digested away and converted into bone. So this is showing during fetal development, you have bone that starts out as cartilage, because we're seeing this light blue, and then what happens, as I just said, you get this bony splint that's put on the outside, and then the process of ossification happens on the inside of the bone. We have 3 main types of bone cells. We have osteocytes, osteoblasts, and osteoclasts. Osteocytes are mature bone cells that once were osteoblasts. Osteoblasts are bone-making cells, which I call bone builders. And they're actually so good at their job that they will make bone 360 degrees around themselves, and then they encase themselves in that structure called the lacunae, okay? Osteoclasts are bone crushers, and when we need to do bone remodeling, or let's say we don't have enough calcium in our blood, osteoclasts are stimulated to break down or digest bone in order to either, again, restructure the bone or to put calcium into our bloodstream. At birth, as I said, most of the process of ossification has occurred, except for a couple areas. And as we age, our bones are going to grow in length as well as in width. And it is about the age 25 when your skeleton has kind of finished doing all the things that it needs to do. And then it's just maintaining, and then potential changes can occur if we are deficient in certain things. Growth of our bones is controlled by 2 different things, growth hormone and sex hormones, okay, specifically testosterone. So for appositional growth, which is growth wider, if you will, osteoblasts and osteoclasts have to work together in order to restructure and cause even growth all the way around, okay, that bone. It's important that that happens, and it's important that you may have heard that, when you're working out, you don't just want to just work out your left arm and never work out your right arm, okay? You need to work out both sides of things. It's not only important for muscle development, but it's also important for bone formation and growth as well. Two factors will additionally stimulate the remodeling of bone. Number one is the calcium levels in our blood. Do we have enough or do we not have enough? Two is the pull of gravity, okay, in our muscles on our bones. So using your skeleton. Using our skeleton and the amount of calcium in our body is going to determine how active our osteoblasts or osteoclasts are and how much bone remodeling or reabsorption of bone is going to happen. So calcium is super important. It's not just important for your bones and your teeth, as you've heard, I'm sure, for your whole life, but it's actually important for every single nerve impulse that's set in your body. It's important for every single skeletal muscle contraction. All this dancing I'm doing right now is because of calcium. When our blood calcium is too low, the parathyroid gland, which sits on top of the thyroid gland, it's a separate gland, secretes parathyroid hormone. PTH, or parathyroid hormone, stimulates osteoclasts to break down bone matrix and deposit calcium into the bloodstream till we get back to our homeostatic amount. The opposite is true if our blood calcium is too high. The thyroid gland produces a hormone called calcitonin that suppresses osteoclasts and activates osteoblasts, the bone builders, to make bone. So in this little slide, it's saying if you have an increase in blood calcium, so we have too much, it's going to cause calcitonin to be produced. Calcitonin will send a red arrow to the osteoclast and say, no, we're not breaking down bone right now, but it sends a green light to the osteoblasts, okay, which are all of these cells lining the outside of the bone right here to produce bone. As you can see, the osteocytes, they used to be osteoblasts, but they built bone around them and ended up becoming osteocytes. If you have a decrease in blood calcium, that will cause the parathyroid hormone to be produced, which sends a green light to our osteoclasts to break down bone and put it into our the calcium into our bloodstream. Again, those won't continue to happen. There's a negative feedback mechanism that we learned about in Chapter 1. Bone remodeling occurs when we use our skeleton. When we don't use stuff, we lose it in our body. That's true for muscles. That's also true for our bone mass. So it's really important for us to maintain movement, stress, lifting weights, things of that nature. It's important for our bones. This is also just talking about PTH and how bone reabsorption occurs. So during fetal development, all of the long bones are converted from cartilage to bone, except for those epiphyseal plates. And then we actually have those soft spots in the skull that we talked about where the bones are not fused together. Well, they're fused, but the joints are fused, but they're still cartilaginous, so that the skull can compress during vaginal delivery. And again, ossification of those fontanelles are all going to be complete by the age of 2. And that's just showing a little fetal skeleton where the skull itself has not fully gone through the process of ossification. So that should be bone. So that should be all white right there. And then look at the wrists. So the wrist hasn't fully gone through ossification. Yes, there's like no carpal bones that you can see, again, because those have not fully gone through the process of ossification yet. We talked about the curvatures of the spine. We talked about how babies are born with a C-shaped spine, and then they do things like crawling, standing up and walking, and they have to carry that big heavy head, and it ends up causing a change in the curvature of the spine to develop the secondary curvature. And if you think about the face, babies have kind of like a squished face, like a pug almost, and then the face literally kind of grows out of the cranium, grows out in a way like this. Just interesting how the facial features develop. So again, during childhood, teenage years, our skeletons will end up developing until about the age of 25. Puberty, because of testosterone, estrogen, there's going to be some differentiations of the skeleton. And like the female pelvis will widen, the male skeleton bones can become thicker because of testosterone, and usually there's an increase in height. Okay. So as I said, activity is really important in order to maintain our skeletal system, or our bones, okay, and our density of our bones. If you don't use it, you're going to lose it. As we age, our ability to maintain the density of our bones can decline, particularly for women after menopause, which means that their ovaries stop making estrogen, and estrogen in itself helps women maintaining their bone density. So postmenopausal women may struggle with osteoporosis and fractures. Trying to get the screen to go here. Here we go. Oops. All right, fracture. So a fracture and a break of the bone are synonyms for each other. They mean the same thing. We have two main classifications. We have open fractures and we have closed fractures. Open, which can also be called a compound fracture, means that it is opened, the skin is broken, and bone is sticking out. A closed fracture is when the bones are broken, but the skin is not broken. Things stayed inside. A fracture is treated with reduction, and we have two different types of reduction. We have closed reduction and we have open reduction. Closed reduction is when there's manipulation to try to coax the two bone ends back together. And then open reduction is just another way of saying surgically fixing something. When a fracture or break, again, those are synonyms, occurs, there are four things that happen. And you need to pay attention to this because you probably will have to put them in the order that they occur. Hint, hint, wink, wink. First thing is that a hematoma forms. That hematoma is like a bloody blister, okay? Blood is going to be spewed to the area. Why? Numerous factors. Well, the bones have a really good blood supply in them. And they will, blood is going to increase the rate of metabolic activity. You've got platelets and white blood cells and collagen fibers and all sorts of good things in your blood that are going to go there to stage, they basically are setting the stage for repair. Cartilage is going to be put in place just to replace the bone that was broken. The next step is going to be a bony callus is going to be kind of paper mache on the outside of that bone. And then over the process of weeks to months, bone remodeling is going to occur. So you've got that collar on the outside. You have to excuse me, I'm also in a Teams meeting waiting for it to start. You've got a bony callus on the outside, and cartilage on the inside, and then what's going to happen is that the cartilage is going to get slowly going through the process of ossification and be replaced by bone. This is a femur fracture. This is it looks like comminuted femur fracture into multiple pieces. It doesn't look open from this picture. There are different types of fractures. Comminuted is when the bone is broken and it's broken into several pieces. Compression is when the bones are broken and then they just, squeeze into each other. I believe I'm getting that one right. Depressed is when you have like a skull fracture and it's gone inward. Impacted is when, again, those bones they break and then they kind of go across each other in different planes. Spiral is when there's a twisting, and a green stick is when you have, instead of a break kind of across in a bone, let me see. I don't have any bones near me that I can use. Instead of having a break like across a bone, there's a longitudinal type fracture. You're not going to have to know the different types of fractures for the test, but you should include some of that information in your outlines. All right, that is it.